It is the most annoying accessory you own. You buy a sleek, razor-thin laptop that weighs almost nothing, but to keep it alive, you have to carry this, a heavy, clunky, rectangular brick. It gets hot, it trips people over, and it takes up space. But have you ever stopped to wonder why? Why is there a brick in the middle of the cord? Why can't we just have a simple wire running from the wall to the computer, like a lamp or a toaster? The answer lies inside this black box. It isn't just a plug, it is a miniature power plant, a translator, and a bodyguard, all wrapped in plastic. Today, on Simple Things Surprising Histories, we're cracking open the casing to find out exactly what happens inside your laptop charger. To understand the brick, we first have to understand the problem. The electricity coming out of your wall is chaotic. It's alternating current, or AC. It rushes back and forth, changing direction 50 or 60 times every single second. It's high voltage, usually 110 or 220 volts. Think of it like a high-pressure fire hose. But your laptop, it's delicate. Its microchips need a steady, calm, one-way flow of electricity, called direct current, or DC, at a much lower voltage, usually around 19 volts. If you connected your laptop directly to the wall without the brick, the high-voltage AC would instantly fry the motherboard. The black box exists to mediate this negotiation. It has to turn a raging river into a gentle stream, and it does this in 3 distinct stages. Step 1 happens the moment electricity enters the box. It hits a component called a bridge rectifier. Imagine 4 traffic guards standing in an intersection. No matter which way the traffic tries to come from, these guards force all the cars to drive in the same direction. The bridge rectifier takes that back and forth AC power and flips the negative waves up, creating a rough, bumpy one-way road. But rough isn't good enough for a computer. That's where the biggest component inside the box comes in, the capacitor. You've probably seen these. They look like little soda cans. The capacitor acts like a water reservoir. When the power surges, the reservoir fills up. When the power dips, the reservoir releases that stored energy to fill the gap. It smooths out the bumps, turning that choppy electricity into a straighter line. But we still have a problem. The voltage is way too high. In the old days, lowering voltage required a massive, heavy bunch of iron coils. If we used old technology, your laptop charger would weigh 5 pounds. Modern chargers use a clever trick called switch mode power supply. Inside the brick, a tiny transistor acts like a gatekeeper. It chops that smooth, high-voltage DC current up again, flashing it on and off tens of thousands of times per second. Why do we do this? Because of physics. By turning the power into high-frequency pulses, we can use a tiny, lightweight transformer to step the voltage down from 220 volts to the safe 19 volts your laptop needs. This is the magic of the brick. It's not just letting electricity flow, it is actively chopping, resizing, and rebuilding the power thousands of times a second, faster than you can blink. Finally, there's a hidden safety feature called an optocoupler. This is the Bodyguard. It physically separates the deadly high-voltage side of the charger from the low-voltage side that touches your hands. It uses a beam of light to send signals across the gap. If the voltage gets too high, it tells the switching transistor to slow down. This ensures that even if something goes wrong inside the brick, the dangerous wall power can't jump the gap and shock you or destroy your computer. So, the next time you trip over that blocky power cord, remember, it's not just a piece of plastic, it's a complex city of bridges, reservoirs, and high-speed switches working tirelessly to keep your digital life running. This is Simple Things Surprising Histories. If you enjoyed opening this black box with us, hit that like button and subscribe for more surprising histories of everyday objects. See you next time.